Network 1 has a positive edge pulse coil or positive one-shot. Network 2 has a negative edge coil or negative one-shot. Each pulse coil gets assigned a unique memory bit which tracks the incoming logic and determines when a pulse should be fired through to the coil. Network 3 is used to reset the output set coils for networks 1 and 2. Turn the monitoring glasses on. Memory bit 63.0 keeps track of the result of logic, or RLO, just before the P coil. When the RLO transitions from 0 to 1, a positive edge pulse or one-shot is fired through to the set coil M300.0. This means if I0.0 were true, and I0.1 transitions to true, a positive edge pulse or one-shot is fired, and the set coil M300.0 goes true. Let's reset coil M300.0 with input I1.7. Here input 0.1 is true. If 0.1 is true and I0.0 transitions to true, a positive edge pulse or one-shot is again sent to the coil. So either input can be true, and when the other transitions to true, the result of logic or RLO transitions from 0 to 1, and the positive edge pulse or one-shot is fired. Let's reset the output coil again with I1.7. The negative edge pulse coil fires a pulse or one-shot on the trailing edge when the result of logic changes from 1 to 0, regardless of the order of change. For example, if I1.0 is true, and I1.1 goes true, and then I1.1 goes false, a pulse coil is fired, and the set coil M300.1 goes true. Let's reset the output coil. If both I1.0 and I1.1 are true, and this time I1.0 goes false, the pulse will be fired and the coil M300.1 goes true. So if both inputs are true, then if either one goes false, the pulse is fired. In review, a positive edge pulse coil fires a pulse when the result of logic right before the positive edge coil transitions from 0 to 1, regardless of the order in which the logic goes true. The negative edge pulse coil fires when the result of the logic before the negative edge coil transitions from 1 to 0, regardless of which bit logic goes to 0 first. And that concludes this video.